station. This is Houston. Are you ready for the event?
Houston, this is station. We're ready for the event.
ESA, this is Mission Control Houston. Please call the station for a voice check.
Station, this is Christer Fugelsang. How do you read me?
Men hejsan, Christer. We read you loud and clear.
Hej Jessica, härligt att höra prata svenska. Hello Luca also. We are here at the Nobel Prize Museum in Stockholm with 3 Nobel laureates who are very eager to ask you some questions and talk to you. And they will each ask one question each for each of you. And then if you don't answer too long, I hope you will also have some questions for them. So let us start by giving the mic to Didier.
It's an amazing moment. Ooh. Luca, from the International Space Station, you should enjoy a view on our own planet that many of us would love to see in their own eyes. We can only dream to obtain similar perspectives on all planets that we have detected on other stars. How much do you think the Earth view from space is inspiring to look for exoplanets?
I can only express my own personal opinion and feelings when I talk about the view from up here when I look at the Earth. On the hours and the days before coming back to ground last time on Expedition 36 and 37, I remember having this very distinct thought come to my head that even though I had been looking and admiring the curves and the colors and the liveliness of Earth, I was very lucky because that was my planet and that's home. And if I had been an alien coming from I don't know where, from an incredible voyage, looking down at our planet, I would have desired nothing else than just land and enjoy the sights from up close. So I think that yes, it does inspire us because our planet is beautiful and amazing, and it's our only planet right now. And if we could find signs of planets that are similar to our Earth, it would be an amazing discovery. And I think that we are heading in the right direction. Our technology and our science helps us both imagine but also getting closer to those planets. And so I think that our views of our own planets from up here are a very strong inspiration.
Jessica. So, Jessica, I have a question for you. As a marine biologist and physiologist, I would be really curious to hear your thoughts about the prospect to detect life on exoplanets and what kind of life forms you would envision personally.
Yeah, as astronauts, we get asked about other forms of life frequently during interviews, and I think we would be very naive to think statistically that there is no life on other planets. And of course, that's why there is so much effort in looking for life. One of the interesting things to think about is, of course, that life might not look anything like us. It might be entirely different. It might not even be carbon-based. It could be based on an entirely different combination of molecules. And it may be something that we don't expect at all. Going back to that background in marine biology, it reminds me of when hydrothermal vents were discovered in the deep ocean crevices back in the 70s. In the late 70s, actually, I think it was the year that I was born or the year before, that researchers from my very own graduate school, from Scripps Institution of Oceanography, discovered those first hydrothermal vents. And until that time, people had this traditional view that life, of course, was always based on harnessing energy from a sun or some kind of equivalent star. The photosynthesis, which of course we learn about in grade school. With these hydrothermal vents, we saw for the first time these thriving ecosystems that were based entirely on chemosynthesis. So the chemosynthetic bacteria were fueling this. There was no light getting down to those significant depths. Scientists had thought maybe it's this marine snow that is falling from above that is providing all the nutrients, but it wasn't that. It was actually the chemosynthetic bacteria that were supporting themselves from the sulfur in these hydrothermal vents, supporting that amazing ecosystem. So I think that's a really interesting analogy to think we may find something completely unexpected that may change our perspective about what life truly is.
Yes. I don't have question on the dynamics of the microphone, but I have a question to Luca. Please, space science, exploration, research require patience, dedication, and commitment. What are the goals that you have been striving for, and how did you keep your motivation up during your full career? What is your advice to young scientists, young students with a passion for space science and exploration?
Well, I'll answer the second question first because it's the easier answer. I think that the most important thing that I would suggest to anybody that wants to be involved in the future in space, science, technology, exploration is stay curious. Don't ever accept a fact, don't ever accept an answer as a given. Just be curious, question everything. Up here, we really love getting answers and finding answers to questions and finding new technologies, test new experiments. But I think that every time we find an answer, there are 10 more questions that rise up. And I think that that's even more interesting because our curiosity is sparked by those questions. So to anybody at any school level, at any grade level, from kindergartners all the way to grad students and postdoc, stay curious. Our universe has really an infinite amount of questions to be answered, and so by being curious, you will always be inspired to question more, to do more, to strive for the next thing. And as far as I'm concerned, my curiosity has certainly been a driving factor. I'm not a scientist. I'm more of a technician, coming from an operational background. But that doesn't mean that I cannot be very curious about what surrounds me. I'm constantly asking questions from people that know a lot more than I do about stuff that I don't know anything about: physiology, biology, astrophysics, chemistry. Some of my best friends are professors in Italy. One of them is an exoplanetary expert in Turin. Another one is a professor of chemistry in Sicily. And I'm always asking questions, reading books. So that curiosity has always been a driving factor. And then possibly one other thing is just the desire to be contributing somehow. Science, human spaceflight is probably one place where science, technology, and exploration really come together. And if I can give a very small contribution to that path, then I will consider myself satisfied.
Thank you very much. And now I have a much more difficult question for Jessica. In the coming years, we are planning to characterize extrasolar planets, density, internal composition, atmosphere, and so on. How do you see this investigation related to the scientific experiment you are carrying out the IC?
Yeah, one of the most exciting things that we do, of course, is the wide array of different scientific experiments up here on the International Space Station, ranging everything from physiology, medicine, chemistry, combustion science, you name it, we're doing it up here. There have been some experiments that have looked at some of these basic gravitational physics principles. One example is a payload that was called Meteor, and it was installed in an observational facility which provides a great view looking down on the Earth. And this was the first time that observations were made of the chemical composition of meteors as they re-entered the Earth's atmosphere using a visual spectrometer. So if we start using some of these examples to look at the properties and the formation of the composition of these meteors, of course that can tell us a lot about how planetary bodies of all kinds formed in our universe. There's another example looking at this basic gravitational physics of a facility called Hermes and a Hermes experiment, which is looking at how planetary bodies might coalesce. So there are actually some direct applications to, maybe it's still a little bit of a stretch to your exoplanet research, but I think it can tell us a lot about the formation of planetary bodies of the solar system and within the universe.
Thank you.
Jessica, Stan Whittingham here. I understand you've recently undertaken spacewalks to replace the old nickel-based batteries with the new lithium-ion batteries on the exterior of the station. How do these batteries compare with those you've been used to in the past?
Well, first of all, for all three of you, it is truly an honor to be speaking with you and these scientific greats like the three of you today. And Dr. Whittingham, we understand that as the founding father of rechargeable lithium-ion batteries, we have you to thank for our significant power upgrades here on the International Space Station. And you're right, we were conducting these spacewalks just a couple months ago. We were upgrading the power channels with these nickel hydrogen batteries that we used in the past with the new lithium-ion batteries. And they have a significant performance advantage over the older batteries. Namely, we are replacing 2 nickel hydrogen batteries with 1 lithium-ion. So a very significant capacity advantage there. And they are actually certified to be used for 10 years instead of the 6.5 years of the previous batteries. Now, I think it's really significant for spaceflight to look at that mass advantage, 1 battery for 2 batteries. Of course, everything that we launch up to space is incredibly expensive and takes a lot of effort to get up here, so that was a big savings for us. So we thank you very much for your contribution to the International Space Station.
So, Luca, following on that, space is an extreme environment. Are there particularly operating restrictions for your lithium-ion batteries in terms of hot and cold and other activities?
I just came back from last Monday. I was out with astronaut Drew Morgan for another extravehicular activity, just like Jessica performed a few weeks ago. And we know from experience that when we are in the shade, it gets really cold really fast. I think that the surface temperature is about minus 150, minus 180 degrees. And when we are in insolation, it's the opposite, about 150, 180. So obviously, it's a very extreme environment. So yeah, the batteries, the new batteries and the old ones, but especially the new ones, the lithium-ion, they need to be somehow thermostabilized. So here in orbit, convection doesn't work, because gravity affects convection. Density doesn't have an effect up here. So in order to thermal stabilize them, we use solar heating and an ammonia-based cooling system to keep the batteries as thermally stable as possible. And that way, we ensure continuous energy inside the station from the solar array during the day pass and from the batteries during the night pass. There is another thing that is important about the lithium-ion batteries. We have them inside the station in our portable computers. We have computers all over the space station for personal use, for work, and they run on lithium-ion batteries. Now, when they came on board, we found out that there might have been chances of a thermal runaway. I think that's the expression, where they get so heated that they might become dangerous. So we actually had to swap some of our old carbon dioxide fire extinguisher with water mist based ones, and so now we have about we have distributed among the station this water mist water extinguisher. Now I hope never to have to use it, and if one day they expire, maybe we might take a shower. That would be a better use for them than trying to extinguish a fire.
Jessica and Luca, amazing to see you, the roaring applause here. And now I invite you. Do you have some question you would like to ask our Nobel laureates?
Well, the first question is similar to what you asked me. I would really like to know what the recent hypotheses are, or what your hypotheses are for what the first sign of life that we could find might look like.
Yeah, I think I was interesting to hear you because you're a biologist, and there is a different perspective from the physics perspective on this question that try to start from maybe some more unique-based principles. So right now there is a lot of progress has been done on the chemistry producing the amino acids, for example, and we're trying to bridge the Earth science or the planetary science perspective into the formation of the chemistry, which is going to drive to life. In a way, life is a kind of a chemistry experiment that turns bad because it leads to something that gets out of control. And we're trying to get the piece of the ingredient which is needed, both from the astrophysics perspective, which means what do we need on the planet, or what kind of delivery do you need to make this possible? And then we want to make sure we understand the chemistry that's going to drive. It's a long way, but given the progress that we have made in the last 10 years with the discovery of planets and now the detection of the atmosphere on some of these planets, I think there is a hope with the next generation of space equipment, the James Webb Space Telescopes, and the next generation following this, that we may be facing life discovery in the next 50 years. And it's always hope that there is life on Mars, and we're going on Mars. So let's just maybe wait a bit.
Thank you very much, Didier.
We're both happy to go to Mars.
We still have time for... Yeah, Luca, the question.
Yeah, my question is going to be very short and mundane, but it's for the three scientists and engineers there. It's a very yes or no questions. Many people, they always ask us if being an astronaut was one of our dream, and everybody has a different answer. But today I'm going to flip the question. I suppose that, you know, being a Nobel Prize laureate for a scientist or engineer is a dream. It's a lifetime achievement. Would you swap place today? Would you want to be an astronaut if it meant that you didn't get your Nobel Prize?
Yes, that's a difficult question to answer, particularly at maybe my age. As far as younger, yes. I don't know if it's compatible with the barb to be an astronaut.
Yes, I would, because I think nothing prevents an astronaut to get a Nobel Prize.
Well, I'd like to thank you so much on the station, Jessica and Luca, and I'd like to thank Michel and Stan for being here, and I enjoyed this discussion so much. Thank you, ISS. Handing over to Houston.
Tack så mycket, Christer. Hejsan, alla i Sverige.
station. This is Houston ACR. That concludes our event as we count down to 20 years of continuous habitation in space aboard the International Space Station.
Thank you to all the participants from ESA. For the ISS crew, we'll now be resuming operational space-to-ground communications.